breaking the data barrier. Low-cost laser communications prove scalable for deep space. The recent Artemis II mission has achieved more than just a lunar orbit. It has provided a successful proof of concept for a new era of space communications. While NASA's primary goal was to send 4 astronauts around the moon, the mission also served as a high-stakes test for laser-based data transmission, proving that high-speed connections between deep space and Earth can be achieved without exorbitant costs. A breakthrough in high-speed downlinks. Traditionally, spacecraft have relied on radio frequency (RF) transmissions to communicate with Earth. While reliable, RF technology lacks the bandwidth required for the massive data loads demanded by modern high-definition imaging and complex scientific sensors. During the Artemis II mission, a specialized terminal developed through a collaboration between observable space and quantum, OPUS successfully intercepted data broadcast from the Orion spacecraft. Operating via the Australian National University, this terminal achieved a data rate of 260 megabits per second, successfully pulling down 4K video from the lunar orbit. Innovation through affordability. The most significant takeaway from this mission is not just the speed, but the accessibility of the technology. Cost efficiency. The experimental terminal used in Australia cost less than $5 million. In contrast, traditional, bespoke deep space communication systems often command price tags in the tens of millions of dollars. Technical synergy. The system combined observable space's software and telescope technology to lock onto the spacecraft's signal with a specialized photonic sensor from Quantum Opus designed to decode the data. Global reach. Because laser communication requires a direct line of sight and can be interrupted by cloud cover, having ground stations distributed globally is essential. The use of an Australian site highlights the necessity of a distributed, international network to ensure continuous connectivity. Why this matters? Moving beyond satellites, laser communication, or optical communication, is already a staple for satellite-to-satellite links, but transmitting that data back to Earth has historically been too expensive for most players. The success of the Artemis II test suggests that the cost barrier is falling. The implications for the space industry are vast. Scaling infrastructure. Companies can now envision a global network of low-cost terminals capable of receiving data from various types of satellites. Democratizing data. Lower costs mean more organizations, not just massive government agencies, can participate in deep space exploration and high-bandwidth data retrieval. Commercial integration. Observable Space has indicated plans to scale this technology over the next year, potentially partnering with ground station-as-a-service providers or large satellite constellation operators to build out dedicated infrastructure. The mission proves that space-to-Earth laser downlinks are ready to scale, notes Dan Rolker, CEO of Observable Space. Conclusion: by successfully receiving 4K video from the moon using a relatively inexpensive terminal, the Artemis II mission has demonstrated that high-speed, deep space laser communication is no longer a luxury reserved for elite agencies. This breakthrough paves the way for a more connected, data-rich, and commercially viable space economy.